Hello and welcome to this video. In this video, we will learn about higher order functions of Rust. So this is the first example from Rust by example. In this example, what we will do is the objective is to find the sum of all the numbers with odd squares under 1000. So the first thing we do is we take an iterative approach. So upper is set to 1000 and then we have an accumulator, okay, and we iterate from 0 to infinity. All right, so this n is our loop and this is our range 0 dot dot. We square the number. If the number is squared number is greater than the upper limit, we break. Else we check if it is odd or not. This is the is odd function where we pass n squared, and if it is the remainder is 1 when divided by 2, we add it to accumulator, and finally we print this. The other approach would be to use functional methods. So I will show you all the methods. So in this case, we create a range, okay, range from, and then we map that, and map will operate on each number from the range and compute the square. And then what we do is we take the reference of that squared number and we check if it is less than upper, and this is the take while. So this will operate till the n squared is less than upper. And for filtering, filter will apply this function is odd on that n squared number, and finally it will sum them, and we print the sum of squared odd numbers. So I did not tell what is a higher order function. A higher order function is a function which takes a function in its parameters. That is one case, and second is it can return a function as a parameter. So either when a function takes another function as parameter or returns a function, those types of functions are called higher order functions. So we have these two approaches, imperative and functional approach. So we run this Carco run, and it prints the same value 5456 in both the cases. Now, if uh, you don't know where these functions have come from or how to use them, for example, if you mouse over, it will show the documentation. But if you see carefully, this has come from iterator, this has come from iterator, this has come from iterator. So most of these will come from iterator. So for example, sum, if you see, all these are declared and implemented in the same file iterator.rs. So if you see the outline, there are lots of such iterators are available. For example, next, next chunk, size hint, count, last, advance by, nth. So lots of iterators are there, and you don't need to worry that how to use it. For example, this is filter map. So filter map, if you see, the example is given. You have, for example, this vector. So you filter map, you do s.parse, okay, and that will give you sum 1 and sum 5, because only 1 and 5 can be passed to integer, but 2, 9 and 4 cannot be. So this filter is preceded by filter map is preceded by filter, which we have used. So in this case, if you read the documentation, it says that creates an iterator which uses a closure to determine if an element should be yielded. Given an element, the closure must return true or false. The returned iterator will yield only the elements for which the closure returns true. So similarly, here our closure is odd. It makes use of is odd, and is odd returns a boolean because we have an equality operator here. So it will return either false or true as indicated by its return type bool. So when it will return that it is true, only then this n squared will be considered. Otherwise, it will be dropped from here, and then sum will finally sum them. So this is the uses of filter which is given. So you can look at this iterator file. It will be available, for example, in your lib, rust lib, src, rust library code, src iterator, traits iterator.rs. So all iterators are defined here. You can make use of it. Other library functions may also define certain iterators, and you can look at their documentation, whichever you are referring to, and you can simply click the function to take you to the code. For example, sum is here. So give an example is you have a vector here and you iterate on that. You create an iterator of that vector by calling iter function, and then you simply sum it. Okay, so sum would be 6. This is an example. So here we are getting a vector of numbers from here, which will contain n squared, and we just sum them. So don't worry if you don't understand much of it. Once we are done with the syntax of Rust, we will delve into functional programming of Rust. So this is one such example of higher order functions. Let's see another example of higher order function. We close this and we add another folder, open folder, and we go to videos, Rust programming, and we see HOF. Okay. So what we saw that the function which we have discussed was a closer. Okay. Now we look at this. In this case, this is an anonymous function. Okay. This particular section is an anonymous function. It does not have a name. I think I have shown anonymous functions earlier also. So we have, we are calling a function binary operator, which takes 2 arguments of type i32, and it takes a function actually. It may be anonymous function, it may be a named function also. I'll show you the next example which will have similar named function. So this is of type F, where F is of type fn i32 i32. You will recognize fn from our closure discussion. So this function also returns i32, that is op, and the function binary operator also returns i32. So we simply invoke the function on the function supplied in the parameter. We invoke that on parameters. So it is 5, 6, 5 minus 6 would be minus 1. So we go to HOF and we run cargo run at prints minus 1. And then we see a named function example, say open folder, and we have this. So in this case, instead of passing anonymous function, we have a named function add. The other things remains same. This add function simply adds it. So it will be 11 this time, 5 and 6 will be 11. Last time it was minus 1. So we say cargo run and we have 11 as the output. So the general idea is that a function can be used like a normal parameter. You just have to specify types in this manner and that will work out. So the idea of higher order function can be very useful. The reason is why it is more useful is because of this. I'll show you. Close folder. Yeah. So if we look at our first example, which we studied, if we look at the first example, if you see both the approaches, iterative and functional approach. So let's start from here and we start from this line. So we have line 25 to 10, that is 16 lines of code we had to write. But in functional approach, it was 33, 6 lines. Okay. So you see, code is less than half. Okay. The only thing is you have to attune your mind to functional approach. It takes some time to get uh, talking to yourself in terms of functional approach, because most of us, when we come from Python or C or C++ or Java to Rust, then we find this functional approach a bit different. But if you are coming from languages like Lisp or Scheme or Haskell or OCaml, then this will appear very natural to you. The main idea to the main idea to learn functional approaches is to learn all these iterators. Unless you know what is available to you, you can't use it. So as an exercise, what you can do is you can read this file, iterator.rs. That's quite a big file, but you will learn a lot. It is 4,000 lines, so it might take 2-3 days, maybe a week to fully understand it. But even if you are not interested in the actual implementation, what I will suggest you to read this documentation portion in front of every function. For example, if you see zip, so what it does, even though you don't want to, or rather at this stage, you can't understand this. For example, you don't understand this at right now. We don't know what is intuitor. We have not discussed. We don't know what is U or something like that. Sized, we don't know right now. But what we can learn is this section. Okay, the documentation section. From here to here, we can understand what is going on here, because we have to use JIP. So we read this and we understand and we try to use it. So that's the idea of higher order function, to implement a functional approach to solve the problem at hand. Functional approach, when we talk of functional approach, we typically mean a functional programming language. There are benefits of functional programming languages. One of the benefits, there are two benefits, is functional programming languages make use of the concept of immutable variable a lot, and tail recursion, plus they have no side effects. A pure pure function will have no side effects. So these are the benefits which you get along with uh, the short number of lines of code. The other thing which is possible with function is it is far easier to prove a functional program in terms of mathematics compared to iterative approach. If you try to write a mathematical proof for this, it will take a lot of effort as compared to this one. So places where accuracy is of very high importance, for example, in compilers or chip verification, the functional programming languages can help you a lot, because there'll be far less errors which you will have in functional programming language. It is easier to identify problems in functional programming languages, that this is where my mistake is. In iterative, it is far harder. The problem which you will face is actually that you have to learn to think in terms of functions. But that's a matter of practice. With practice, you'll get better. So as an exercise, I would suggest that you read the documentation of this file. And I think that's it. So I'll end this video here, and I hope that you find this video useful and informative. Let me know in comments what you think, or what other topics you would want videos on, or how I can improve videos more. And I will try to accommodate your comments in my future videos. Thanks a lot for watching. Happy programming.